Let us talk about, now we are going to take a closer view at the gastric gland. Okay. So, we have first of all, this is the floor, okay, this floor, this is the stomach, okay, and I know there is a hole there, there is on the gastric pit. All these cells here, they are all these cells here, they are all mucus secreting cells. They are all what? Mucus secreting cells. Very simple, plain mucus secreting cells. Okay. All. Okay. The complication happens when you enter into the gastric pit. And now let us see what happens into the gastric pit. First of all, in the gastric pit, at the more or less at the neck, near the neck, this is the end of the gastric pit. This is the mouth of the gastric pit. I will call this as the neck. The neck, there is a huge population of cells, which is can you read for here? Read me for there. Stem cells. Now, please remember, just as your skin, huge amount of mitosis is continuously happening in your skin, so that we get rid of the old cells. Are you with me? Basic. Okay. Similarly, along the entire length of the, some of the, if I ask you, tell me some of the tissues where the mitosis continuously happening, your first answer will be bone marrow. Hello, bone marrow, and the second answer perhaps would be skin, okay, hair follicles, okay, and the third answer will be what? Will be a lining of the alimentary canal continuously cells are happening. Fourth or fifth answer may be your nasal mucosa. I'll take the pendulum to the other end and tell me the name of an organ where you will find minimum of mitosis. Brain, okay. Is brain devoid of mitosis altogether? No. Okay. There are cells in the hippocampus and the subventricular gray, okay, where the, I am not going to talk neurobiology, it is very tempting. Okay. So, we are, the mucous cells, okay, and then let us go a little, okay, I will tell you here, and somewhere here are parietal cells and somewhere deep inside are chief cells. Take a step back and let us find out what cell is where. It is mucous cell, little deep inside it is mucous cell, below that there is stem cells, and please remember the stem cells keep on coming and they keep dividing and they keep on moving. Some of them go towards the upper end, some of them go towards the lower end, and they keep on replacing the old cells. That is the regeneration is continuously happening in the wall of the stomach. And then a little deep inside we have the parietal cells. Parietal cells are the acid secreting cells. So, please fill in the blank. Acid secreting cell is called as what? Parietal cell. Parietal cell is also called as Oxyntic cell. What did I say?
Parietal cell is
also called as Oxyntic cell. And what is its main function? To produce huge amount of hydrochloric acid. What acid? Hydrochloric acid. So tell me the name of parietal cell. Good. And if you go deep into the pit, almost by the where the pit ends, okay, these cells we will call as what? Chief cells. These are pepsinogen contained secreting cells, and pepsinogen is a large protein molecule that will be broken down. It will give rise to pepsin, which is an enzyme which will act in the acid medium. We will talk about it shortly. Okay. Now, let us see, okay. Now, what author does is here is the structure of the gastric pits taken from the fundus is slightly different from the gastric pit taken from the antrum. Have I made my point clear? We are talking of, now I am talking of two gastric, there are hundreds of them, I am talking two samples. One is taken from fundus and other is taken from where? Antrum, and I am trying to draw the distinction between the two, and they are relatively here. Okay. See, there is a mucous layer here, there is a mucous layer, these are mucous cells here, these are the surface cells, these are mucous secreting cells, these are here, they are there in both, but they are a little more in the antral gland, but they are there in both. We are okay so far? Okay, good. Then let us see what are these bluish cells here, these are what cells? Parietal cells, but no parietal cells here. Have you appreciated the major difference between the two? Whereas the fundus part is loaded with thousands and thousands of parietal cell, you hardly find any in the case of what? In the antral part of the stomach, you don't get them. Are you okay so far? Okay. Then the green ones are there in both. These green ones are what? Progenitor cells, which means stem cells, which we have already seen in the previous one. So, you have them here, you have them here, progenitor cells have to be there everywhere. Okay, good. Then there are, this is something, now this character is coming for the first time, two characters are coming for the first time. These dark blue cells, they are called as ECL cells or Enterochromaffin cells. What do you call them as? Say that again, Enterochromaffin cells. What did I say? Enterochromaffin, they are there in both. Enterochromaffin cells are there in both. Now, what are these enterochromaffin cells? These are, I will tell you, you have to just, it has to fit there. They are histamine secreting cells. What are they? They are histamine secreting cells which act locally. Locally means what? Locally means what? The histamine secreting cells, what is the immediate neighborhood of the histamine secreting cell there? Look at there and tell me. Parietal cell. It is in the vicinity of what? Parietal. So enterochromaffin cell, I will make a statement. Enterochromaffin cell, by secreting histamine, it stimulates the parietal cells. Okay. So, the control is there only. Okay. Are you with me so far? So, who is talking to whom? Is talking to parietal cell. What is the medium of communication? Medium of communication histamine. Good. Then yet another major difference is the occurrence of these red cells. Here, they are not here. So, where do you get the G cells and where you do not get the G cells?
In fundus you will not get the G cells.
Very good. And where will you find them?
Antrum.
Find them in the antrum. G cells are responsible for secretion of a hormone. So, stomach is an endocrine gland and the hormone is gastrin. And why gastrin is called as a gastrin? Because it comes from stomach and it is a protein hormone, therefore, gastrin. And it comes from where? It comes from these cells which are located in, where are they located? In the fundus or in the antrum part? Antrum part, okay. Okay, so these, I said gastric glands, right? I used the word gastric pits and gastric glands. Author has used here the Oxyntic gland for this. Can you guess why author has used the word Oxyntic glands for this? They are parietal, these are Oxyntic cells, they are Oxyntic glands, and antral gland is rich in the G cells or the gastric secreting cells. Yes, please.
Why are there ECL cells in the antral part if there are no parietal cells? They act on the parietal cells.
Okay, now let me tell you why this question is not very relevant. This is a highly simplified diagram. Okay, this phenomena is far more complicated. There are at least half a dozen more types of cells, okay, and at least 2 dozen receptors known there, about which I am not talking. Okay, so your question is bona fide. Within the framework of what we have done, your question is genuine. But your question cannot be really answered unless I go to the broader picture, to which I am not going. But your question, I respect the question, but I am not going to answer it. Okay. Yes.
Can parietal cells still secrete in absence of any stimulus from ECL cells?
Wait for 2 minutes. We'll go to the entire. This is just a small part. Okay. Okay. Oh, I put this slide. I'll answer your question in a minute. This is histological section through the stomach here, somewhere here. Can you see this slightly lighter cell? This cell here. Can you see the pin here? Can you see the arrow here and lighter cell? It's a histological section to show the parietal cell. Okay, within the, okay. All right. Let's move on. I am sure you know what we are talking about in that image. The outline is very clear. And then I will draw your attention to the fundus part. In the fundus part, the author talks about what cells? We have seen abundance of what? Parietal cells. And we also know that parietal cells are a very important source for what? HCl. Okay. Now you have observed these facts. Observe one more fact. Parietal cells are also a source for yet another protein which is called as intrinsic factor. What do you call it as? Say that again. Say that again. Intrinsic factor is comes from where? Comes from where? Okay. Now you can of course ask a question, what might be the rationale for or logic for having the intrinsic factor. We will talk about it in details, but at the moment, to satisfy your curiosity, intrinsic factor plays a very important role in the absorption of vitamin B12. no intrinsic factor, no matter how much vitamin B12 you take, it will not be absorbed. It is very critical, and it is coming from the same cell. The cell that secretes HCl is also the same cell that secretes, and intrinsic factor is important for absorption of vitamin B12. We will see to that later. Okay. So, this is the story here. Then of course, all over there are cells which we call as in the chief cells, and they secrete pepsinogen, which is a large protein molecule, which and in the antral part you have the G cells, and of course, the mucus is there everywhere. All right. So, we have the this tells us about you can read about this, the overall, the tubular gland, how much of gastric acid secreted, how much about the intrinsic factor, etc., etc. But I would rather go on to this. This is a beautiful slide. You can immediately identify the it's a vertical section through the wall of the stomach. At the top somewhere there is the lumen. Are you with me? And these are, can you see those fine gastric pits there? Hello. These are all gastric pits here. Those. Just for that, this is a gastric pit. They are all gastric pits there. So what they have done is they have taken a section, okay, a frozen section, okay, and they have stained it with antibodies against the protein, and that protein is the hydrogen, okay, potassium pump. We have 100 times we have seen sodium potassium pump. Okay, now this time author tells us about what? Hydrogen potassium pump, and hydrogen potassium is nothing but the source of secreting hydrochloric acid. So this is a parietal cell. What you are looking at is a parietal cell. So the author has labeled the parietal cell for us specifically, and what is the marker he has used? Antibodies against the protein. Antibodies against the protein, and by using the immunocytochemical technique, the author shows us. So oh, this is a beautiful image. What is this image? You take a single cell. This is a single dark cell. Each dark dot there is a cell. What is that? It is a parietal cell. You take the plasma of the cell. Okay, that cell, plasma on the apical side, because from the apical side the acid will come into the lumen. Okay, and in that is sitting this beautiful huge protein. Okay. This protein, like sodium potassium pump, also has alpha unit which is very big, a beta unit is very small, two proteins. What they have done is they have only taken the alpha unit and then purify it, inject it in rabbit. The rabbit will generate antibodies, take the antibodies, put it on the section of the stomach of the rat, stain it, okay, develop a color, and every cell that has the protein now looks dark brown to me. We are good so far? And so now let us see what is happening within a single cell. Oh, so where are we? We are attempting to find out how a single parietal cell secretes acid. Good so far? Okay. So here we have a single cell, a huge cell, a parietal cell has been drawn for us by the author. This is the lumen, and this is the basal side. The moment I see basal side, I start looking for the pump, and the pump is there. Okay. And there is something interesting, because there is another pump here, and what is that pump called as? Hydrogen potassium pump, and that hydrogen potassium pump is on the luminal side or apical side or the basal side? It is there, it has to be there on the apical side. Oh, good. So this pump keeps on working, and this also like this pump also, it is the potassium ion, and there is a potassium channel, it keeps on circulating, but what it does is every time it goes through a cycle, okay, there is antipode system, it will drive, and it uses ATP, it is a pump, it will drive those hydrogen ions to the outside. Now, where do the hydrogen ion come from? It comes from, author tells us that water split into OH and H ions. Okay. This OH ion will combine with carbon dioxide, which is everywhere. It will give rise to what? It will give rise to what? It will give rise to what is this? Bicarbonate ion. Are you with me so far? And the bicarbonate ion will be driven out by way of what you call as anion exchanger, which means what? The chloride is exchanged for now. By now we are very familiar with anion exchangers. Now this time you can't give me a strange look, okay? We know where anion exchangers are. Was it in the intercalated cell of the kidney? This time I am not lying, right? Intercalated cell, right. So there is an anion exchanger, and so we have the because the H ions go, and there is a chloride channel there, okay, because the H ions go, the H ions will draw the chloride ions, positive, negative, positive, okay, and then you will have a build up of the huge amount of so there are hundreds of cells, each cell will put on its own actually each cell puts on thousands and thousands of H ions, thousands. And you know something, for every single H ion in the blood there are a few million H ions in the stomach, huge. But here is the beauty, osmolality of the fluid is still 300. Osmolality is still 300. I mean, you are replacing one ion with another ion. I am talking about what osmolality of the blood, 300. Intracellular, those cells, 300. Osmolality everywhere is 300. Beauty, biology is amazingly beautiful. I mean, you have so much of a particular ion species there, okay, but you still keep the osmolality is still 300. Amazing. Okay, and then so are we good with this slide? Can I move on now? Okay. Hello. It takes time to absorb. I know. So I would suggest that you go home and spend 10 minutes just looking at this diagram. Okay, just to it has to go to, I mean, how beautifully the cell is separating, okay, separating the ions in one compartment with now. For every H ion which goes, look at my hand, which goes in this direction, there is one bicarbonate ion which goes in this direction, 1 to 1, 1 to 1. Okay, are you okay so far? But I will say here that whereas the hydrogen ion is a product of my interest. Why it is a product of my interest? Because the gastric because the pepsin enzyme which will come from pepsinogen, which will come from chief cells. The pepsin can act at pH 2.5. Okay. Actually, as a result of the secretion of the H ions, it is so acidic that the pH is almost 0.8. 0.8, just imagine, it is very concentrated hydrochloric acid, but it doesn't remain 0.8 because it mixes with the food that we have taken, and as a result of that food slightly buffers it, and then the pH goes to about 2.5. So the actual digestion is happening at about what? 2 to 2.5. Okay, so far. Now, so what is the product of my interest is H ion. Bicarbonate ion is a byproduct. Are you okay so far? Now an interesting question is coming. I want you to apply your mind. A byproduct is coming. Okay, are you okay so far? In any good engineering system, forget about biology. In any good engineering system, or any engineering system is really good if you are going to employ the byproduct to some use. You got the question now? At least understood the question. If you have appreciated that, then tell me, in what way can you use this can you put this byproduct to use?
It can go to the small intestine.
Huh?
It can go to the small intestine or the pH is high.
Very good. Absolute brilliant genius. She is right. Why? Because when the food goes to duodenum, you need to neutralize it. Neutralize it with what? Bicarbonate. Those bicarbonate ions are transported from the wall of the stomach eventually to the duodenum, okay, and that it is released with the pancreatic juice, it is released into the duodenum, so that all those acids are neutralized. Brilliant. So at the level of stomach you separate them, okay, and then at the level of duodenum again you make them and it is neutralized. So the pH of this duodenum is about actually slightly more alkaline, 7.2 to 7.4. Okay, great, very good. I am very happy with that answer. Yes, go ahead.
In this slide, what is the significance of Na plus hydrogen exchanger? Because it's throwing hydrogen into the blood.
Oh, that is a it's very low concentration. It's I do not know that, you see this is an observation that hydrogen goes here, but this is far less, as compared to that. I am not answering your question because I do not know, okay, but this is a electron photomicrograph of the parietal cell. And what is a peculiarity of this cell is huge number of canaliculi. Now, what are these canaliculi? Canaliculi is membranes, they are all membranes, okay, and those membranes are intracellular. In the parietal cell, they are intracellular, and those membranes are loaded with thousands and thousands and thousands copies of the pump. So, can you see this pump here? Can you see this only pump? Can you see this membrane here? Hello, hello, hello. Can you see the membrane? Can you see these pumps? They are not pumps. This is a membrane. Sitting on if I take a tiny bit of the membrane, on that I may get 1,000 copies of this of the pump molecule. Okay, therefore, every cell there are thousands and thousands. 1,000 may be too small, far large number. And how it works is, so this cell is more or less a complete closed cell, and there is an extensive system of membranes. We call them as canaliculi. What do you call them as? Canaliculi. And but after the arrival of the food, and when the cell is stimulated, okay, this suddenly, can you see this? These membranes are exposed to the outside, okay, and suddenly those membranes on which the pump was sitting, which was intracellular, okay, now it is exposed to the outside, okay, and once it is exposed to the outside, it can secrete the hydrogen ions, and then the hydrogen ions and the chloride, and then it can go into the answer is actually here. This is the diagrammatic view. This is a resting stage of the parietal cell. Can you see those vesicles there? And on each vesicle, can you see the green dot there? What does the green dot represent? It is a pump, okay, and then you stimulate the cell. There are many ways to stimulate the cell. One of them could be by way of histamine, and then as a result of that, then when it happens, these again traffic. The traffic, they merge with the plasma membrane, and once they are here, they start secreting hydrochloric acid, and the hydrochloric acid will be released into the lumen of the stomach. Are we good so far? Hello? Are you good? Okay. This tells us something. This again, we have done this. So these are here are the stem cells. The cells give rise to these cells, and they migrate. So as they migrate, they will specialize into different kinds of cells, and the green ones are the parietal cells, and the blue ones are the enterochromaffin cells, parietal cells, mucus secreting cells. Chief cells are in this part, etc., etc. And the author has abbreviated the function of each for us. We have already done that. Briefly, we have already done this. This slide is interesting because it tells us what molecule are we talking about? Histamine. What is the source here? ECL, enterochromaffin cell, and in the plasma membrane, on the basal side of the plasma membrane of the parietal cell, you are going to get this receptor. It is again a G protein coupled receptor. Are you with me? Look at the receptor which goes up and down. So somewhere here is the site where histamine can combine, and once it combines, it excites the cell, and the cell will start so a patient comes to you and says that I have an acidity problem. Okay, look at this image and give me a solution. Antihistaminic. Okay, you can use antihistaminic. Okay, and for a very long time, when I say for a very long time, I mean 1990, 95. Almost 2000 till 2005, one of the most widely used drug for controlling acidity was cimetidine. What was cimetidine? What you said? It was H2 receptor. This receptor is H2 type. H1, H2 are system receptor H2 type, which are involved here. You could block the receptors and you could do it. Are you with me? Now you didn't ask me a very interesting question. What happened after 2005? I will come to that because that answer is very exciting. But before you come to that, let us, okay, so what are we looking at? Okay, so the major problem, you are secreting so much acid, and then why doesn't it digest the stomach? Okay, why doesn't the acidity eat up the stomach? Well, it will if you damage the mucus layer. Okay, therefore, there is a very thick mucus layer. And that mucus layer, actually in the lumen of the stomach, it is almost 1 mm thick. Okay, and as we know it, so here we have a very funny. I mean, this is biology again. You want this is the pH here is almost 7. This one mm thick layer has pH as about how much? 7. It is coming in contact with the fluid where the pH is how much? pH 2. So is neutralization happen? Of course, it is happening here. Okay, but the only solution to that problem, you know, something we have addressed this problem with reference to the high osmolality in the medulla. High osmolality in the medulla, I mean you have to completely keep on doing it, okay, because the natural forces, the laws of physical chemistry will bring about equilibrium. So what is your solution? Your solution is to keep on let these cells keep on generating bicarbonate. Okay, so and keep on and the parietal cells, let them keep on pouring in hydrochloric acid, so that remains at about 2 as long as the food is there. Okay, and this remains at about 7. You get the argument? Is there a partition separating the two pHs? No. So is some titration going to happen? It's going to happen. Okay, but this mucus actually, you know what happens is in the case of the people who have a gastric ulcer. Okay, it's invariably because there is a bacteria called H. pylori or something, Helicobacter pylori. Am I right there? Okay, that bacteria can damage this layer, and once this layer is damaged, then the inner the mucous layer of the stomach proper is exposed, and then the acid can start, and then it's a okay. It's very interesting slide. Let's understand this. This is another slide on which I want you to spend some time. Okay, so here we have the mucus here, and this all pH here is the pH here is 7 and the pH there is 2, and here are our parietal cell. And you know something, as you go deeper into the gastric pit, the mucus layer becomes very thin. As you go deeper and deeper, it becomes thin. It's very narrow. It's a 1 mm. It's 1 mm thickness when you go into the lumen of the stomach. Okay, from the lumen of the stomach, if you enter into the gastric pit, the layer becomes very thin. It goes on becoming thin and thin and thin. Okay, and it's very thin by the time you reach the. Therefore, they are deep. In the gastric pit, there is a parietal cell, and this parietal cell is secreting the H ions. Is H ions coming in contact with the mucous layer? Okay, the answer to that question in strict sense, yes, but the layer is extremely thin. Okay, so when the large amount of H ions can come, okay, they can still pass through it, because the mucous layer is extremely thin. Had the mucous layer been thin, all H ions will be neutralized there only. They can still go through and look at the arrow, H ions, and then H ions goes through this. Then the H ions go through as if they go through a tunnel, and that tunnel is made up of what? Mucus, and that layer becomes thicker and thicker and thicker. Okay, and then you enter into the stomach. There's mucus layer on both the sides, but in the lumen, okay, there's no mucus, and that's where the food will come, and that's where the H ions will go, and hydrochloric acid will go, and these are the sensory fibers. The brain wants to know what is happening in the stomach, and at the same time, just as the H ions are going here, I want to draw your attention to the point number 4, which author is showing us. What is the point number 4? Bicarbonate ions. Okay, so as you take your food, and as the stomach is releasing hydrochloric acid, on the other side, on the plasma side, the cell is releasing equal amount of bicarbonate, and this phenomena is called as, beautiful word, you will appreciate the word, love the word. What is the word? Very nice word, isn't it? What is the word? Alkaline. What does the tide mean? Sudden. As much as H ions are going on that side, sudden increase. So if you literally keep on monitoring blood samples, okay, from the stomach when you are fasting and when you are having food, okay, you will suddenly find that there is too many H ions, and accordingly the pH also slightly varies in the blood. Okay, you can read about the alkaline tide.